Hey everyone, this is Jaime, and today I'm going to be talking about my fourth assignment in my Turing Scholar class. And this assignment was basically to make Tetris. Now, Tetris is pretty easy, but we kind of delved a bit further into it. So if I open this project, you can see all the files we have. And the first part, simply create Tetris. They provide a backend GUI, and you provide the actual methods, the backend methods. So with all this set, what the cool part about this is not actually playing Tetris. So I believe this is the correct file. If I run this, you can see Tetris 2000. What are the keys? Here are the keys. I'm not really familiar with the keys. Didn't really play too much of it. But it's nice. So this is the entire program itself. I'm gonna go ahead and stop this and quit out. Now, what the interesting part is, if you can look here, you see all these JBetterBrain, JBrain, Tetris, Headless Brain Test. Now, what we did was we basically made a heuristic that would score a board. So our AI that would play Tetris basically evaluates every single possible move and sorts them on a priority queue. Now, with this priority queue, it determines, I think it goes back down two different steps. So it checks the first step, evaluates that, and then delves doing a depth first search, searching for the next move and evaluating those tests, and tries to find the best subsequence of optimal moves. So with this, you can have a program that runs fairly nicely. So I believe, is it JBetterBrain? No, this is just a class. So I'm gonna have to find this. Here we go. I believe this runs it. So Tetris 2004. Don't know why that's different. If I run this, I'm not clicking anything. It's running on its own. I'm gonna speed this up just a little bit. Not too fast, but you can see we have something playing the game on its own. So I'm gonna try to make this a little faster as we go along. Each green instance is a clear line. You can go a little faster, and it's doing pretty well actually. Um, there are different components that we use to evaluate what would make a good heuristic. I'm going to put this aside for now and have it running in the background. So let's see. I believe it's in our JBetterBrain, and yeah, we have 5 variables that we're checking for. We have max height, average height, variable height, which tells you the basically the variation of height, the whole weight, and the whole depth. So right now we're not actually using whole depth, so this is actually void, but the whole weight. So we're simply using these 4 variables, and we actually get pretty good performance. So what this does is a max height. We determine the maximum height, so the greatest height of the current board, and we give that a weight of 35. So it's pretty important, but not too important. Oh wow, our program just lost. Interesting. I'll start that up again. So, and then we have our average height, which is pretty important. We want to keep a consistent height. We don't want to run too high of a game. We have our variation of height, and that's not too important. And then we have our hole weight. So it's very bad to have holes, and what I mean by holes is little gaps that you see occasionally within your game. So if you like stack a block here or there and you see you have a pretty big hole, then that's bad. You don't want to have that, so we really don't like that. After it rates all the boards, it does what I basically explained previously and evaluates it. So how did we come up with these weights? This was a problem that we had to figure out on our own, and it was a bit of an extra credit kind of thing. So I'm going to close this out. We basically tested everything. So we initially began with this slide and watch.java file. So if I run this, it creates a new GUI, and it has less sliders just for fun, and we run our program. So I'm going to run it fairly quickly again, and you can see it looks like it's doing pretty well. Right here we can adjust in real time what happens. So let's say hold depth is really important, we make it something really strong, we lost. It's not, you should never be that high. We completely disregarded it because it changed every single value we put it with it. It just completely destroyed our project's performance. So we can change the whole way. We can change the max height. Let's change the max height to be a little bit more important. You can see that it started to get a little bit higher. It's not doing too bad. But yeah, you can change every single thing in real time. You can see how everything affects the other thing, but it's not really the best. Running this GUI takes a lot of resources, and it doesn't run quite as fast as you would like it to. So we decided to take a different approach, just for a little bit more fun. We have this line graph class that extends JComponent, so it's another GUI. And what this does is when you run this, you still have your sliders, but now it graphically represents and dynamically scales your average performance. So each one of these nodes is actually a score, how many pieces were placed per game. And as you can see, this is running tons of games extremely fast. We actually slowed it down so you could visually represent everything in a little confined area. Right now, I believe the limit on the number of nodes is around 10,000. So we have about 24,000 right here. We have a peak of 43,000 now. We have a few outliers. We can easily see the average score we usually receive. Unfortunately, it's not too high. I thought it was a little bit higher. But if I were to slightly change something, you can see real-time adjustments. So if I go ahead and change the average height weight a little bit more, changing it, changing it, changing it. Wow, I didn't know the average height wouldn't really affect much. I guess the average height is usually around the same area, so that's why that's happening. Let's go ahead and change the variation height. Oh, that really messed things up. So as you can see, variation of height isn't very good to have as a high indicator. Um, but yeah, this is the program and all. I enjoyed making this. It's actually really fun. I hope you enjoyed the video and tune in for more. Thank you.